In this video, we will discuss about shortest subarray with or at least k. You are given an array nums of non-negative integers and an integer k. An array is called special if the bitwise OR of all of its elements is at least k. Return the length of the shortest special non-empty subarray of nums or return -1 if no special subarray exists. So what they are saying is that in the input, we are given an array which consists of positive integers and we are given an integer k. Now what we need to do is that we need to find a subarray of this array which is special. So a special subarray is the one where the bitwise OR of all the elements is at least k. Point to note at least k, right? And you need to return the length of the shortest subarray that you can achieve, right? So basically, we need to find out a subarray with the bitwise OR as at least k, right? And it should be of minimum length. So this minimum length you need to return as your answer, right? So if you see in these cases 2, 1, 8 and k is given to you as 10, when you will do the bitwise OR of these three elements, it will come out to be 11, right? This 11 is greater than or equals to k, right? It is at least k. So in that case, your answer is going to be 3 because that is the smallest subarray that we can create out of this array where the bitwise OR is at least k, right? So now how are we going to approach this? So let's try to find out some of the hints. See, we are given that we need to find such a subarray where the OR is at least k, right? Now there is one property of OR that is going to help us here. So if you see, these are the numbers that are given to me. So 2 in binary is 1 0, 1 in binary is 0 1, and 8 in binary is 1 0 0 0. Right? So now if I will try to do the bitwise OR of these numbers, so first if I do for this 2 and 1, then it will be 1 0 0 1, right? So what will be its OR? It will be 1 1, right? Which in decimal is 3, right? Now if we do the bitwise OR of this 3 with this 8, then what we will get? So it will be 1 1 and then 1 0 0 0, right? So these two bits will be 0 0. So now your OR will be 1 1 0 1, right? Which is nothing but 11. Right. So now if you see here that when we did the bitwise OR of 2 and 1, we got 3, which was greater than both 2 and 1. Right. Then when we did the bitwise OR of this 3 with this 8, then we got 11 as the answer, which is greater than this 8 and 3. So whenever we do the bitwise OR of some numbers, whatever is the resulting OR, that is always greater than or equals to the elements of which we are doing the bitwise OR. Why? Because see, how does a bitwise OR works? So whenever the two bits are 0, it gives 0. Whenever one of them is 1, then it gives 1. And when both are 1, then also it gives 1. Right? So there is no case when the bitwise OR unsets a bit. Right? Either it keeps the bit as is or it sets the bit. Right? So either it keeps the number as is or increases that number. Bitwise OR never decreases a number, right? So what I am saying is that as you will move forward in this array, your bitwise OR is always going to increase, right? Whenever you are doing bitwise OR of 2 and 1, then at that time the bitwise OR will be either equals to this 2 or greater than this 2. Out of these two, this one is the maximum. So the OR is going to be either equals to this 2 or greater than this 2. Then out of this you got 3. Now with this 3 you will do the OR of 8. So now your bitwise OR will either be equals to this 8 or greater than 8, right? So as we move forward, our bitwise OR is going to increase, right? So we will try to utilize this point in finding out our answer, right? So now if you see, we want to find a subarray, right? Subarray meaning a consecutive part of my array, right? So this 2 1 is a consecutive part, 1 8 is a consecutive part, 2 1 8 is a consecutive part, 1 is a consecutive part, but 2 comma 8, this is not a subarray, right? So we need to find a subarray with or as at least k. So now how should we proceed further to identify such a subarray? So if you see, I am saying I want a subarray. Now for a subarray, if let us suppose that this is my array, right? Then for a subarray, we always have a pointer I and a pointer j, meaning start of my subarray and end of my subarray, right? For a subarray, you are always going to have a start and an end. I'm denoting them with I and J over here, right? So in this entire array, this could be your subarray, this could be your subarray, this could be your subarray, right? So basically, any subarray can be my answer, right? Now I need to find out that what are all the valid subarrays, meaning I want to find out all the subarrays where the bitwise OR is at least k, and then I want to find the minimum length, right? So this particular subarray, if we are considering, and I'm saying that it can be any subarray, then can I say that this is nothing but window, a window that I am considering out of my array, right? And this window can be anywhere, right? So can I say that this subarray will be going to be nothing but a sliding window, and we will try to slide it, or we will try to expand or shrink it on the basis of the bitwise OR value that we are getting, right? So see, what we can do is that, so let us suppose that you are considering this particular subarray or this particular window right now, and the bitwise OR of this subarray is less than k, right? It is less than k. Now what you want is, you want the OR to be at least k, right? And as I said, as you will move forward in the array, your bitwise OR will increase, right? So if my bitwise OR is less than k, then I want to increase it, and for increasing, what I will do, I will expand my sliding window to include this element also, right? So there might be a possibility that my bitwise OR becomes at least k if I include this element, right? So in that case, I will try to expand it, right? So earlier I was considering these three elements, this much subarray. So now since bitwise OR of these many elements was less than k, so I will consider this element also into my subarray, and then I will try to find out the bitwise OR of these many elements, right? And now again, if the bitwise OR is less than k, then I will try to accommodate this element also, right? Now what if some subarray gives the bitwise OR as at least k? In that case, what you will do? So see, we want to minimize the length. Whenever my subarray has the bitwise OR as at least k, in that case, I want the minimum length. So I will try to shrink my window, right? So that I can minimize the length, right? So if let us suppose that this particular window was giving me a bitwise OR as at least k, right? So what I will try to do is, I will try to shrink this window so that I can minimize my length, right? So I will try to remove this element from my window, and I will check for these many elements that what is the bitwise OR I am getting, right? If it is still greater than equals to k, then I will try to get rid of this element also, right? Then if it is still greater than or equals to k, I will try to get rid of this element also, right? Till my I and j becomes equal, I will try to keep on shrinking my window until my bitwise OR is coming as at least k, right? So through this, I will be able to identify the smallest subarray where the bitwise OR is at least k, right? So what I said was that if at any point, whatever is your current window, if its bitwise OR is less than k, in that case, you will try to expand your window. So you will consider the next element also into your window. And if in case it is greater than or equals to k, that is, it is at least k, then you will try to shrink your window. So whatever is the first element in your current window, you will try to get rid of it, and then you will find out the OR of remaining elements. And then again, you will follow the same procedure, right? So now for this, we should know the bitwise OR of our current window, right? Whatever are the elements in your current window, you should know their bitwise OR, right? Only then you would be able to compare it with K, right? So if let us suppose I am considering this window, and then I am taking this element, my bitwise OR is less than K, so I will expand my window and I will take this element. Then in that case, whatever is the XOR of these many elements, let's denote it with X. Then in this X, you will do the bitwise OR of this element also, and now you will get the bitwise OR for this window, right? But what will happen when you try to shrink your window, right? In that case, whatever is the contribution of this particular number in your bitwise OR, you need to cancel that out, right? So now there is no straightforward approach to cancel the contribution of a particular number in a bitwise OR. So for that, we will have to think of some workaround. So now how are we going to do that? So if X is my OR of current window elements, right? So what I can do is that somewhere I can store the count of each set bits in X somewhere, right? So basically what I'm saying is that for this 2, in binary it is written as 1 0, right? So here it will be, this will be the 0th bit and this will be the first bit, right? So what I am saying is that whatever elements I am considering in my current window, I will keep the count of the set bits. So now let us suppose I have an array, right? I have an array or a vector. This is 0th index, this is first, this is second, this is third, this is fourth, and so on, right? So now here in this two, 0th bit is 0, but the first bit is 1. So what I will do is that in this array at the first position, I will update it to 1. Others will be 0, right? Then when you will consider this 1, now you are doing the OR of this 1 with this 2, right? So it is either going to keep the bit as is or is it going to set it, right? So what we can do is that, see, in this case also it will be 0 1, right? So now here in this one, at the 0th bit, 1 is present, right? So what we can do is we can count. In this array, we will count that, okay, at the 0th bit also I have got a set bit, right? So you will update this to 1. Again, when you will come to this 8, then what you will do? So this will be 0, 1, 2, 3. So you'll see that, okay, at the third bit I have a 1. So in my count array, I will update the third bit. So I will increase it by 1, right? So now if let us suppose there was one more number, 5, right? So that would be 1 0 1. So this would be 0 1 2. So then that means at the 0th bit, I have got one more 1, and at the second bit, I have got a 1. So this will become 2 and this will become 1, right? So this array will basically store the count of set bits for whatever numbers we are considering in our sliding window, right? So now whenever you are expanding your window, at that time you are doing the OR of the new element, right? So in that case, at whichever bit positions the bit is set in that particular number, you will increase the count of those bit positions by 1 in this particular array, right? So now what will happen when you will have to shrink the window, when you want to cancel out the contribution of a particular number? So let us suppose that at this point the bitwise OR becomes at least k. So now you want to cancel out the contribution of this 2. You will try to shrink your window. So now for cancelling out the contribution of 2, what you will do? You want the bitwise OR of only these elements, right? So you will remove the contribution of this 2. So how are you going to do this? So in this 2, there was only one bit set which was at bit position 1. So what we'll do is that in this particular array, we will decrement that particular bit position by 1, because we are removing that element now. We are removing the contribution of that element from our bitwise OR, right? So this will become 0, right? So then with this array, you can find out the bitwise OR, right? So here the count is non-zero. So this you can take as 2 to the power 0. Then this is non-zero. So this will be 2 to the power 2. Then this is non-zero. So this will be 2 to the power 3, right? So you can do, okay, 1 plus 4 plus, right? So this will give you 13. And if you will try to find out the bitwise OR of these elements, you will see that it will come out to be 13. So by keeping the count of the set bits of the numbers that we are considering in the current window, we will be able to cancel out the contribution of a particular number from the bitwise OR whenever we are trying to shrink our window, right? So this will help us in solving our question. So let's see the code to understand how are we going to implement this. So see, we want to return the shortest length as our answer, right? And if it is not possible, then in that case, we want to return -1, right? So what we'll do is we'll take a variable length and we will keep its initial value as int max, right? Because we want to minimize the length. That is why we are taking a greater number, right? Now what we want is we want two variables which will denote the start and end of our sliding window, right? Or we can say the start and end of our subarray. So we will create two variables, start and end. Both will be initially 0 0, right? Now what we want is we want to store the bit counts, right, of the numbers that we are considering in the current window, right? So we will create a vector of type integer. Let's name it bits. So now in the constraints, the maximum number in the nums array can be 10 to the power 9, right? And 10 to the power 9 in binary is represented with 30 bits. So here you can create an array of length 30, and initially you will keep the count of all the bits as 0, right? Now what you want to do is you want to expand or shrink your window to find out your answer, right? Until when are you going to do this? While your end is less than nums.size, right? Because as soon as we reach the end, we cannot expand our window further, right? So we will check that while our end is less than nums.size. Now inside this, what are we going to do? So see, we will try to add the next number into our current window, right? To check what is the or that we are getting, right? And since we are adding this particular element into our current window, we will have to update the bit counts also, right? So here we will call a function update bits, right? In this we will pass our bits vector, right? And then what will pass? The number that we are taking into our window, right? And what is that number? That number is nums of n, right? So now for updating the bits, we will do a +1 when we are taking an element, and we will do a -1 when we are removing that element. Basically, whenever we are expanding the window, that time we will do +1 for all the set bits, and whenever we are shrinking the window, at that time we will do a -1 for all the set bits, right? So in this case, we are expanding the window. So what we'll do is we will pass a 1 here, which will denote what has to be done for the set bits, right? So here we will create a function which won't return us anything, and it will be update bits, right? So it will receive this vector which will be bits. So we are passing it by reference here so that we don't have to return it again, right? And the next thing that it will receive will be the number, right? And the next thing is the operation that we are going to perform, which will be either +1 or -1, right? Now inside this, what you will do is you will check for all the 30 bits. So we'll run a for loop of I equals to 0, I less than 30, I plus plus, right? And then inside this, what you need to check is that if the ith bit in num is set, then in that case you will have to increment the count of that particular bit position in bits by 1, right? So here you will check that if the ith bit in nums is set or not. If it is set, then in that case, at the ith position in bits, you will add the operation, right? So when you will send a 1 here, then 1 will be added to this ith position, and when you will send -1 here, in that case it will be decremented by 1, right? So now that you have updated the count of bits, what is the next step? The next step is to check that what is the bitwise OR that you are getting for the current window, right? So now for finding out the bitwise OR of the current window, again let's create a function. So this will return us an integer, which will be our bitwise OR. So we can name it binary to decimal, right? Because it will convert our binary number into decimal. And what it will receive? It will only receive the bits vector, right? It will only receive the bits vector. Now inside this, what you will do? You will create a variable result, which will be the OR, right? And then you will loop for the 30 bits. I will be 0, I less than 30, and I plus plus, right? And then inside this, you will check that if the count of bits at the ith position is a non-zero value, then in your result you will add 2 to the power I, right? So basically here we are converting our binary number into decimal so that we can get the bitwise OR of the current array elements, right? So wherever the bit positions are non-zero, there we are doing 2 to the power I and adding into our result, right? So here you can return your result, right? So now, as I said, we will keep on shrinking our window until the bitwise OR is at least k, right? So what we'll do is we'll check that while our start is less than equals to end, right? And the bitwise OR of my current elements is greater than or equals to k, meaning I am checking that till I have a valid subarray and the bitwise OR is at least k, you keep on shrinking your window, right? So at every point you will have to update the length, right? Because here the bitwise OR is at least k. So this is one of the valid subarrays that could be your answer, right? So you will have to update the length here. So length will be minimum of, we want to minimize, right? So minimum of length comma, how can you identify the length of the current window? Through end minus start plus 1, right? So you will update your length. Now after this, since we are shrinking our window, we will have to remove the starting element of our current window, right? And the starting element is what? Nums of start, right? So since you are removing that element, you are shrinking your window, you will update the bit counts also, right? So you will call update bits. Inside this, you will pass the bits vector and the number which will be nums start, right? Then since now we want to decrement the count of set bits, we will pass -1 here, right? And you will keep on shrinking your window, so you will keep on increasing your start by 1, right? And then since here you are considering the next element or basically nums of end into your current subarray or window, you will move your end also forward, right? So your end will also be incremented by 1. Now at the last, you can simply check that if your if your length is equals to int max, right? So this, when is this case going to happen? When you didn't get any subarray where the bitwise or was at least k, right? In that case, this length will never change. So if your length is equals to int max, in that case you can return -1, otherwise you can return the length, right? So basically we created a length variable which was having int max as its initial value. Then we created two variables which start and end, which were denoting the start and end of our subarray or the sliding window. Then we created a vector for storing the count of set bits, and we kept it as 30, and initially all the bit counts were 0. Then we ran a for loop while our end is within the limits of nums. Then we took the nums of end element into our current window. So we updated the count of set bits, and then till the bitwise or of our current window was at least k and our start was less than equals to end, we kept on shrinking our window, and while doing that, we kept on tracking the minimum length, we kept on updating the count of set bits, and we kept on incrementing our start, right? And then whenever we are expanding our window, we kept on incrementing our end as well. At the end, we checked that if the length is still equals to the maximum number, then that means there was no valid subarray. In that case, we are returning a -1. Otherwise, we are returning the length. So I hope you got it. So let's run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.